We welcome all of you to the series of discovered questions in science and frequently asked queries from day-to-day life. What makes evaporation different from boiling in terms of latent heat of vaporization? How is the boiling point of water dependent upon atmospheric pressure? I remember during summers when temperatures soared in my city, my mother used to sprinkle water on the terrace and suddenly we used to feel cool. And before the refrigerators became a household commodity, I enjoyed thanda pani from a ghada or a matka. We know in both cases evaporation takes place, but what makes evaporation different from boiling in terms of latent heat of vaporization? How is boiling point of water dependent upon atmospheric pressure? It might be useful to take both these questions together. The heat required to convert liquid water into a gas is referred to as latent heat. It represents the energy required to pull molecules of water away from each other, overcoming their mutual attraction. At low temperatures, only a few molecules manage to escape, those whose thermal velocities are at the upper end of the energy distribution of molecules in the liquid. That is what causes evaporation. As the temperature is raised, more and more molecules acquire energies sufficient to escape from the liquid, and therefore the rate of evaporation increases. When a temperature that is high enough for most of the molecules to escape the liquid is reached, the liquid begins to boil. The temperature, which is after all nothing but a measure of kinetic energy of the molecules, cannot increase any further because any increase in the energy of the molecules leads to their escape from the system. At this point, heat just serves to overcome the mutual attraction of the molecules. But there is more to this drama. The poor molecules attempting to escape the embrace of others in the liquid have to face the pressure of the atmosphere above, including that exerted by their companions that escaped before them. This pressure keeps them close to the liquid surface and many of them return. If, on the other hand, the pressure outside is low, the molecules escape to greater distances. Lowering the pressure enables even those molecules to leave that have not yet attained velocities that would be considered high enough at normal pressure. Thus, at low pressure, the liquid begins to boil at lower temperatures because molecules that are not very energetic can also overcome the barrier. This is the reason that the boiling point of water decreases at low pressure and conversely is raised when the pressure is increased. The latter effect is exploited by pressure cookers. Higher pressures ensure that water attains temperatures well beyond 100 degrees Celsius without boiling, thereby hastening the cooking of food. This brings us to the end of our discussion. And I'm sure now you realize the importance of using pressure cooker, as boiling point of water is dependent on the pressure. And generally we can say that lower the pressure of a gas above a liquid, lower will be the temperature at which the liquid will boil. So dear children, till the next time, keep observing and keep questioning.